Alright guys, today we're going to do section 6.7 in your book, which is about linear inequalities and graphing linear inequalities. So let's remember what an inequality is. An inequality is almost exactly like an equation, but instead of an equal sign, you have an inequality sign, which is the less than, the greater than, the less than or equal to, or greater than or equal to. So those are the inequality signs. Okay, you also have not equal to's. So these are all of the inequalities that we could have, okay? And because we're using inequalities, our answer is not just one answer. It's not just equal to a number. Now we have infinite numbers that it could be equal to. All right, so the graph of an equation, such as x equals 3 or 2x plus y equals 3, separates the coordinate plane, okay? The first section you have is the actual line, the line of x equals 3, the line of 2x plus y equals 3. Then you also have the set that's above x equals 3 and below x equals 3. So we represent that with the less than and the greater than symbol. Okay, and then the 2x plus y equals 3, that's one set of points, but you also have the points that are less than that, the less than symbol, and the points that are greater than that, the greater than symbol. All right, so let's look at an example. Let's say we want to graph 2x plus y is greater than 3. The first thing we have to do is to put it into slope-intercept form. So we subtract 2x from both sides, and so we get y is greater than negative 2x plus 3, which is great because now we know our slope is negative 2 and our y-intercept is 0, 3. We know how to graph that line. We know how to graph, if this was a linear equation, how to graph that. So we kind of already know the first steps, and we just need to figure out, well, what's different? Okay, so since this equation, or since this is an inequality and not an equation, it's not going to include the points on the actual line. So instead of drawing a line for that equation, we're going to do a dashed line. So that way we can show that it doesn't actually include the line. It's kind of being separated by the line. So we're going to have a dashed line instead of a regular line. Okay, so we have to determine which is the solution, above that line or below that line. So in order to do that, we're going to test an ordered pair. We're going to test a point. So we're going to test 0, 0. And so when we plug in 0 into our equation, it's not a solution, right? 0 is not bigger than 3, which means that 0, 0 is not a solution to that inequality, which means that that side of the equation is not going to be shaded. We're going to shade the other side of the line. Okay. So shade the side of the line that contains the solution set. So again, we did not shade this side that had 0, 0 on it because when we plugged in 0, 0, it didn't work. So we shaded the other side. All right, so let's go over the steps for graphing an inequality. Step 1, you're going to solve for y, identify the slope and the y-intercept of the corresponding equality. So the same thing that you do for graphing an equality, you're going to do the same thing for graphing an inequality. Step 2, you graph the corresponding linear equation. Again, exactly what you already know how to do, you're going to do again for step 2. Step 3 is where it gets different. So there's two cases. Case A, if you have a less than or greater than, you're going to use a dashed line because it doesn't actually include the line. However, if you have less than or equal to or greater than or equal to, it could be equal to the line. So you're going to go ahead and use a solid line like normal. So those are our two cases. Now, step 3, you're going to choose a test point that is not on the line and substitute it into the inequality to see if it works or not. If it works, then that's the side you shade. If it doesn't work, you're going to shade the other side. So again, case A, if the resulting inequality is true, that's the side that you're going to shade. Case B, if the inequality is false, you're going to shade the other side. So let's take a look at another example. Solve for y and identify the slope and y-intercept. We have y is less than or equal to 3x plus 5. It's already solved for y. We don't even have to do anything for step 1. But we do have to identify the slope, which is 3, and the y-intercept, which is 0, 5. Since the inequality sign is less than or equal, we're going to use a solid line when we graph this inequality. Then we're going to test a point. We're going to test 0, 0, and 0, 0 works. Okay, so since it works, we're going to shade to the side that contains 0, 0. So here's the line that we graphed using our slope and our y-intercept. It's a solid line because it does have the equal part. Okay, and 0, 0 was a solution, which means that we shaded all of this side. All right, we are done.